Okay, welcome to math today, our first lesson of this chapter. Our goal is to add and subtract fractions with like denominators. We're going to start out with something a little easy here as we move forward. Get this down along with...
Date and page number!
You're welcome. Here is your warm-up. You have 3 problems where you need to find the least common multiple. Go ahead and do your best, and we'll see you on the other side. All right, I have some people here to help me answer or tell you how you get the correct answers for these. Go ahead, Audrina.
So we listed all the factors and found the least common multiples, and found the least common multiples of each factor.
And it was?
36.
Okay. Savannah?
We listed all the multiples, and for number 2, the least common multiple was 30.
Okay, and Rowan, number 3.
Hi. So we listed all the factors and found the least common multiple, which was 36.
And just to clarify, when they said factors, they meant multiples. All right, hopefully you got all 3 of those right. Now that your brain's warmed up, let's get her done. Keep her moving. So let's kind of remember that say we're doing adding and subtracting with like denominators. So remember what like denominators are. Those are fractions that have the same denominators. So we're going to use that to kind of do problems like you see on the board here. It says you can estimate the age of an oak tree by measuring around the trunk at 4 feet above the ground. So the reason why you go up so high is because that's where the trunk is kind of showing its best growth. So the distance around a young oak tree's trunk increases at a rate of approximately 1/8 inch per month. So 1 month is 1/8 inch, grows another month, another 1/8 inch, and so on and so on. So if we know that the denominator here is going to be the same every time, we call that a like denominator scenario. Let's get into our first example. Just skip through that. So let's see what you can do when adding or subtracting with like denominators. So here's a scenario where it says snow is falling at a rate of 1/4 inch per hour. Had some days like that so far this year. How much snow fell after 2 hours? So we can write our answers in simplest form. We can think through the scenario that for every hour it's 1/4 of an inch. So as you can see here, the first thing I did is I listed out 1/4 one time, 1/4 2 times, because that's how many hours the problem asks us to do. So for your notes, the first thing you do once you have your problem written out is you add the numerators. So our numerators are 1 and 1, so when you add 1 plus 1, you get 2. The denominators you don't do anything with, you just keep them going. Since they're both 4, you don't have to change anything. So to keep her moving, 1/4 plus 1/4 is 2/4. Now, it does say write our answer in simplest form, so now we have to find the greatest common factor of 2 and 4 to find out what we can divide by. Also, you probably recognize that 2 and 4 are both even, so you can divide both of those by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So if we're looking for it in simplest form, your answer would be 1/2. And since it's asking for inches, let's make sure before I box it off, it's 1/2 inch for our correct answer. So have this problem written down before moving on. Here's another problem where it says rain was falling at 1/8 inch per hour. So how much rain fell after 2 hours? So how many times do we have to get 1/8 inch? Twice, since there's 2 hours. So again, you add the numerators. 1 plus 1 is 2. And the reason we can do that is because the denominators are already like. So since they're both 8, you just transfer 8. Now we have to put this in simplest terms though. So since both are even, what can we divide 2 and 8 by? You probably say 2 since it's an even number. 2 divided by 2 is 1, and 8 divided by 2 is 4. So the rate here actually after 2 hours is 1/4 inch of rain over 2 hours. If you need to write that example down, please do so before moving on. All right, here are 2 problems I want you to try on your own. I also wrote on the board, label your answers. So make sure you label them before you come back. Good luck. All right, so here are the answers to the 2 problems. So for the first problem, when you add 1/6, 1/6, and 1/6, you get 3/6. but I divided both by 3 since it's the greatest common factor 3 and 6 share. So I was able to simplify the answer to 1/2 foot. For number 2, Wesley was drinking 2/13 gallons of juice each day. If he could continue that for 5 days, 2/13 plus 2/13 plus 2/13 plus 2/13 plus 2/13 gives you 10/13 gallon. So hopefully you got both those right. If you got them both right,
Give us a high five!
alrighty then. All right, so we're going to up the ante a little bit here with example 2. Here we're going to be looking at subtracting fractions, and now I'm throwing in a whole number. So what is it that you can do with a whole number? Well, the one thing you have to know when you're getting a common denominator for a whole number is you have to rewrite the fraction with a common denominator. So you can see we have 1 minus 3/5. 5 is our denominator, so we put that down here. So when we write 1 whole, remember, 1 whole as a fraction has to be whatever our denominator is, and the like denominator we're going to use is 5. And whatever is the numerator has to be the same value as the denominator. So that's why I rewrote this as 5/5. So now from here, all you have to do is subtract 5 minus 3, and you get 2. Now, 2/5 is in its lowest terms because the only common factor 2 and 5 has is 1. So make sure you have on this example. If you want to do the drawing just to kind of show how it all works, you can. You don't have to, though. It's just there to kind of show you what 1 whole looks like. If we broke it into fifths, what 3 of those 5 filled in looks like, and if you subtracted them, what's left. All right, so let's look at a second one here. Now, for both of these problems, they both have a whole number. That's why they're mixed numbers. And they both have a fraction. But what do you notice about the 2 fractions you see here with 5 and 5/12 minus 2 and 1/12? You probably notice that they're like denominators. So because they're like denominators, it makes the math so much easier. So the first thing we have to do is we have to subtract the whole numbers, and then we subtract the fractions, or you can do them vice versa. So the first thing I'm going to do is subtract the fraction part. So 5 minus 1 gives you 4. The denominator stays the same. You do not change that. Then when we do the whole numbers, 5 minus 2 gives you 3. So you get 3 and 4/12, but remember, you can get it into simplest terms because 4 and 12 share a common denominator. They actually share 2, and they also share 4. So I can divide 4 by 4, and that gives me 1. And I can divide 12 by 4, because what you do at the top, you got to the bottom, you get 3. So the correct answer should be 3 and 1/3, because you always want to put it into simplest form. Okay, copy this problem down in your notes before moving on. All right, so here is your practice for example 2. You'll see that there's 8 problems on the board, but we don't have to do all 8. I have 4 extra problems there so that if you want to go through some extra practice with me, if you're struggling, we can do that together. You can always try these problems on your own and then show them to me and say, did I do these right? And I'll let you know. But we're only going to do the bottom 4 problems, so 11 through 14, just because I'm trying to tell Adriana I'm in charge. So 11 through 14, get those done. Come on back. We'll see how you did. Good luck. So for numbers 11 and 12, you had to make the 1 whole a fraction with a like denominator. So for number 11, we keep it as 7. For number 12, we keep it as 8. And remember, 1 whole is always shown by having the same in the numerator as the denominator. So that's how we got those answers. For 13, all you do is you subtract the whole numbers and then subtract the numerators because the denominator is already the same. And for 14, you may have had 4 and 6/14, but you were to put it in the simplest form. So since 6/14, both the numerator and the denominator are even, you can divide them by 2. So that's why we simplified it down to 4 3/7. Give yourself a pat on the back if you got those right.
Oh yeah! I got it.
Jeez. All right, and here's our last example for this video. We're going to deal with looking at expressions. So let's say the scenario says evaluate each expression when every expression with x equals 2/9. So our scenario here is 5/9 minus x. So this is one of those plug and chug problems. So all we got to do is replace x with 2/9. So here's how it should look. So 5/9 minus 2/9. You subtract 5 minus 2, which gives you 3, and the denominators just transfer over to 9. Now, a lot of you are already recognizing that 3/9 can be divided evenly on both. 3 is a common factor, the greatest common factor of 3 and 9. So if we divide 3 by 3, you get 1. 9 by 3, you get 3. So that's why 3/9 can be simplified down to 1/3. Have this example down before moving on. Let me show you a couple other problems. You can write these down if you think you need to. So here we have x equaling 2/9 again, and it's x plus 2 and 4/9. So plug and chug. Plug in 2/9 plus 2 and 4/9. It's easy to add the whole numbers. There's only one of them, so there's 2. And then add your numerators. 2 and 4 give you 6. What do you know about 6 and 9? What's a common factor of 6 and 9? 3. So you divide that by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And that's how you get 2 and 2/3. You can write that down if you want, but you don't have to. And here's another one. So we're going to plug and chug 2/9 in for 8/9. Now when you do that, 2 plus 8 is 10. So now we have what kind of fraction when it says 10/9? You know that to be an improper fraction. So you have to turn it into a proper fraction by dividing the denominator into the numerator. 9 goes into 10 one whole time with 1 left over as a remainder. That becomes your new numerator. So that's the answer there. All right. On your own, I want you to do 6, 7, 8, and 9. So you're going to replace x with 3/10 in every single one of those. So before you start, I'll even help you here by replacing x there, replacing x there, replacing x here, and replacing x here. Good luck. We'll see you on the other side. So here are the answers you should have had. For number 6, you would have gotten 6/10, but to put it in the simplest form, you divide both the numerator and denominator by 2, you get 3/5. For number 7, you would have gotten 4/10. Savannah did that work. Divided both 4 and 10 by 2 because they're even, she got 2/5. Who did 8? Adriana? Adriana did 8, so she got 12/10. You had to turn that from an improper fraction to a mixed number, which would be our proper fraction, yes. Divide 2 and 10 by 2, and you get 1/5 with the 1 whole still there. And then Rowan did the last one. You should have heard her explain it to all of us. It was very interesting. 3 minus 1 is 2, and 2/10, and she divided them both by 2 since they're both even. So if you got them right,
That's how you do math, sweetheart.
oh my gosh. Here's your box of thought. So you got to answer these 3 using full sentences as best as you can with your knowledge.
Just so you know, I didn't say the last part. I said it
I'm
right
still
when I was
recording.
explaining, but-
All right, here's your quiz. You got 4 problems. Do your best, show your work, and make sure everything is in simplest form. And when you're done, come on up to me.
This sounds squishy.
All right, that's your video for today. Thanks for participating, and thank you to our wonderful volunteers that helped me. All right, we're done. We'll see you next time.